Okay, welcome back to the 4.5 notes. And this video is about concavity and linearization. And so just to refresh on what linearization is, linearization is a method of approximating y values using tangent lines, okay? Tangent lines. So what I want to do is talk about how does concavity, help us do this. So here's what we've got. We have a situation where we have an over approximation, okay? And let me draw you an example of something that's an over approximation. So let me just draw a quick graph here. And let me draw something that is concave down, okay? And if I were to come here and draw an equation, or put a point on that graph, and draw my tangent line, okay, what you notice is that all of the values on my tangent line are going to be above my function values on my function. So I'm going to call this f of x, okay, and I'm going to call this y equals mx plus b, okay. And so, I get an over approximation if my function is concave down. So f of x, all right, is concave down. Now remember, if we want to say that something is concave down, we have to say that our second derivative is negative. All right, so we do have to be able to calculate derivatives to do this, okay? And so now let's talk about something that's an under approximation, okay? So an under approximation, okay? Now let me just draw a graph here, and let me draw something that's concave up, okay? And if I were to come in here and put a point somewhere along this function, and then I drew a tangent line like this, okay, what I know is that any point along my tangent line, okay, is going to be below my function values. Okay, I'm going to call this f of x. I'm going to call this y is equal to mx plus b. All right, and so we can easily see that if we have a concave up function, that we are going, our values on our line are going to be less than that. So we're going to say that we have an under approximation if f of x is concave up. Okay, and I know that a function is concave up if the second derivative is positive. Okay. And so let's go ahead and use that information to answer some of these questions. And so it says find the linear approximation L to the function at the point A. So we'll do that. We want to graph both of the functions and the lines together. Based on the graph, in part A, state whether the linear approximation is an underestimate or overestimate. And then we want to compute f double prime of A to confirm our conclusion. So let's just go ahead real quick and, let's graph this equation, 5 minus x squared. And so that's a parabola that opens down, that is shifted up 5 units. So I'm going to call this 5. And so, I've got this value here and here. And so I'm going to go ahead. I know that my y, if I plug in 2 into here, let me just do that real quick. F of 2 is going to give me 5 minus, 2 squared. And so that's going to give me 5 minus 4, which gives me 1. So if I plug in, here's 1. Let me find 2 here. 2 is going to be right here. All right, that 0.21. So I have an x value of 2. I have a y value of 1. I need to figure out what my slope is, okay? So if I take my first derivative and say, okay, f of x is equal to 5 minus x squared. If I take the derivative, f prime of x, that's going to give me negative 2x, okay? And if I plug in 2, if I find f prime of 2, that's going to give me negative 2 times 2, which gives me negative 4. So my slope is negative 4. All right, so the equation of my tangent line, my approximation L, is going to be, and I usually like to just call it y, y is equal to, let me do this, y minus y sub 1, which is 1, is equal to negative 4 times x minus x sub 1, which is 2, okay? So my linear approximation, which is the equation of a tangent line, is going to be positive 1 minus 4 times the quantity x minus 2, okay? And that's my value, all right? And so if I were to graph that, it's going to be something like this, and let me draw that in, okay? And that's my line, okay? This is the line 1 minus 4 times x minus 2. I mean, you guys can, come in here and, put this into y equals mx plus b form if you'd like. But, for AP purposes, this is, what we need just to be able to write this equation, okay? And so we know, based on the graph, that any point that we have here, because we're above, is going to be an overestimate, okay? So part C, to answer that question in part C, this is an overestimate, okay? And so let's go ahead and take our second derivative for part D. And so if f of x is equal to 5 minus just x squared, then f prime of x is going to be negative 2x. And then, if I found f double prime of x, then that's just going to give me negative 2. So because my second derivative is negative, for all values of x, okay, f double prime is less than 0. So f of x is concave down, which means we're going to have an overestimate, okay? And so if you kind of, get lost on something like this and you don't know what to do, I find that it's just a pretty easy way to just draw the picture of what's going on. If you do the second derivative thing and you don't remember this, just draw a picture of a concave down function and a tangent line, and you can easily tell if you're going to have an over approximation or an under approximation. So, and that's all I got. I'm not going to go ahead and do this thing on differentials, so skip that. We'll talk about that some other time, and I hope you enjoyed this. Talk to you later. Bye!